guys? Ninjan. I hope you are all very well. Welcome back. Today I want us to talk about the value of G, and we have to distinguish between mass and weight. Alright, last time we talked about gravitational acceleration. Then we say the gravitational acceleration is given as G m over d squared, where this is the gravitational acceleration. Gravitational acceleration, and you say this is the gravitational constant. Gravitational constant. We say it to be what? We say it is 6.67 times 10 to the power minus 11 Newton m squared kg. All right. Then you say this is the distance between their centers. Distance between the centers. So if you are talking about a single mass, maybe you are talking about a single planet like the Earth. So that is the distance of the radius of the Earth. Because when I'm calculating gravity, I'm calculating a gravity of a stone on top of the Earth surface. So what is the gravitational acceleration of that stone? Maybe if the stone is going further above the Earth's surface, maybe it's in the mountain, Mount Everest, which means the distance increases. Therefore, the gravitational acceleration of an object that is at a sea level maybe Cape Town, is different from the gravitational acceleration of an object in Houghton. So this one will have a greater gravitational acceleration. This one will have a lower, because the radius here is increasing. All right. So then you have to know that the value of G on other nearby planet can be calculated in a similar way using the mass of the planet and the radius of the planet, because you may be asked to calculate the value of the gravitational acceleration maybe in mass, which is a nearby planet. So you have to be able to calculate it, or the moon. You have to be able to calculate the value of gravitational acceleration. So the value differs between planet. All right. Therefore, so does the weight of an object. However, the mass of an object is the same everywhere. If I'm taking the mass of this stone to the moon, the mass will be the same. but the weight will be different. So there's much difference between mass and weight. Let us distinguish between mass and weight. All right, mass versus weight. What is mass? From primary level, we know that a mass is the quantity of matter of an object, which means is the amount of matter an object has. So it remains constant throughout the universe because it's the amount of matter. All right. It also shows how difficult it is to change the state of rest or motion of an object that have greater mass, because it is therefore a measure of the inertia of an object, and it's sometimes known as inertial mass. So that is mass, which means is the quantity of matter an object contains, and each SI units are kg. This is the quantity of matter an object contains. It measures in kg. It is constant throughout the universe. The universe, which means even I'm going to the moon, Mars, wherever planet, I want to say mass here, not mass of Mars, mass of a planet, Mars. Yeah, Elon Musk. So, weight yona is different because it's the gravitational pull the Earth exerts on an object. So weight is the gravitational pull. Gravitational pull the Earth exerts on an object, which means it is a force. Each SI unit is Newton. So that's the difference between mass and weight. And a weight is calculated most of the time is mass times the gravitational acceleration, the weight. Dependa ke ukuthi le gravitational acceleration yakho yakiphi planet. Usually it's 79.8 in our planet to calculate the gravitational acceleration. You can prove it using this formula, because we will use the radius of the Earth, we'll use the gravitational constant, then we'll use the mass of the Earth. You will get 9.78 6 or 7976, dependa ukuthi ukuphi. All right. Then what is the term weightlessness means? An object can truly be weightless if there is no gravitational field. When it is infinitely far from other body or position between body planet, we can say the object is weightless. Because the distance between is far. Equal space, that is where an object can be truly weightless. Otherwise, the object is not weightless. All right. Thank you very much. After this, we are going to do questions on forces. Usually, we use question 2 of past exam papers. All right.